Well, hello everybody, and welcome back to another episode of Math. Hope you're all having a lovely day, and it's about to get lovelier because you're with your boy, Math. So, in the last couple lecture videos, we've discussed fractions, and kind of what are fractions and the nature of them. And in particular, in the last one, we showed that fractions are division. And it's kind of an interesting perspective because we thought about fractions as numbers, but now we're also kind of thinking about them as operations, or like kind of a compressed operation statement. So I said something like a half is the same as just 1 divided by 2. Or a quarter was the same as 1 divided by 4. These were ways that we could express fractions and think about fractions. So if you haven't watched that video yet, I strongly encourage you to go back and do so. But one way we could view fractions was on the number line, and that's what we did with this video. We looked at fractions on the number line. And these fractions, they came between numbers, right? They came between 0 and 1. Right? So we could have like a half right there, or maybe we would have a third here and 2/3 there. Right? So fractions we can put on the number line, but we also know that we could put decimals between these numbers on the number line. And because of that, it's reasonable to think that fractions and decimals can represent the same number, and indeed that they can. For example, a half is the same as the decimal 0.5. But the question is how do we convert between fractions and decimals? So in this lecture, I'm going to be talking about how we can go from fractions to decimals, and the key is to note that fractions are division. Basically, we're going to convert the fractions into division and then use long division to get our decimal. And then in the next lecture video, we're going to look at decimals to fractions. So how do we go in the other direction? So to begin with, let's just do a quick review of long division. Now, in my videos, I've been kind of assuming that you've learned how to do long division already. It's just part of what you normally learn in basic arithmetic. However, some people might want a bit of a review, especially considering we're going into it pretty heavily today. So I'm just going to do a couple problems to kind of give you an idea for long division. All right, so let's say I have this number, 15,504. And I want to divide it by 3. So we're going to take the number we're dividing, also called the dividend, and put that under this little bar thing here. And beside it, we're going to put the number we're dividing by, also called the divisor. And the idea is we just go through each of the digits from left to right, and we see how many times the divisor can go into it. So we start with 1. 3 can't go into 1, right? 3 is too big, so we have to go over to the 5, but we can't just ignore the 1. So we're basically going to be grouping this 15 and seeing how many times does 3 go into 15. Well, 3 goes in exactly 5 times, right? Since 3 times 5 is 15. So since we're saying that it goes in 5 times, we want to basically take out the portion that this 5 contributes. So we're doing 5 times 3 is 15, right? Since 3 goes into 15 5 times, we want to account for that by actually removing this 15. So 15 minus 15 is 0. And then what we're going to do is we're going to focus on the next digit. So the next digit's a 5, so we bring down the 5 and we see how many times can 3 go into 5. Well, 3 can only go in once. If we tried to get it in twice, we'd get to 6, and that's exceeding 5. So we can only put 3 in once. And so because we're putting 1 3 in, we need to account for that by basically removing that from the numbers so that we can look at the rest of the number. So 3 goes in once, so we subtract off 3 times 1, or 3. And then we have 5 minus 3 is 2. 3 can't go into 2, so we have to bring down a 0 now. And now we're looking at how many times 3 goes into 20. So you'll go through a few multiples of 3, and you'll see that 6 is the most we can get into 20. 6 times 3 is 18. 7 would get us to 21. That's exceeding it, so we have no choice but to do 6. So 6 times 3 is 18. So we're going to subtract that out from the number. And now we are left with a 2. We bring down this last decimal here. We bring down this last digit here. And we get a 4. So we got 24. 3 goes into 24 exactly 8 times. So then we can subtract off 24 and we get 0. So there's no remainder here. So the exact answer to 15,504 divided by 3 is 5,168. Alright, so now let's do an example where there's going to be a decimal involved. Alright, so let's do 1,345 divided by 6. So the dividend is 1,345 and the divisor is 6, so we set it up like this, and we do the same process. How many times does 6 go into 1? It doesn't, so we have to look at the 13. It goes into 13 twice, right? 6 times 2 is 12. So we're going to subtract off the 12, because again, this 2 is basically, we're saying, okay, 6 goes into this 13's part 2 times. So now that we've accounted for that, we want to remove that and just look at the rest of the number. So 13 minus 12 is 1. And then we bring down the 4, so now we're at 14. Once again, 6 goes into 14 2 times. So we'll subtract off 6 times 2, or 12, and we get a 2 here. And then we bring down this 5. So now we have 25. How many times does 6 go into 25? It goes in 4 times, right? Since 6 times 4 is going to be 24. So we subtract that off, and we get 1. Now, at this point, we've run out of digits to work with, right? So there's a couple things we could do. First of all, we could say that this is just 224, and then this leftover piece we write R1, or remainder 1. So basically, 6 goes into 1,345 224 times, but there's just one piece left over that 6 couldn't really go into. However, you would have later learned that this basically can continue going, but with decimals now. So what we do is we note that, okay, 1,345 is the same as 1,345.0, right? This 0 doesn't do anything. So essentially, we've extended the digits that we have available to us, so then we can kind of continue on the number like this. And we also have to put a decimal above here just to make sure that the answer we're getting on the top is going to match the correct decimal spot. So now we have a 0, so we'll bring down the 0, and we have 10. How many times does 6 go into 10? It goes in once, right? So now that we have 1, we subtract off 1 times 6, which will give us 4. And once again, we're out of digits, but we can just add another 0, and we can just keep on doing this until we're finished. So we bring down the 0. How many times does 6 go into 40? Well, it goes in 6 times, right? Since 6 times 6 is 36, so then we have a 36 here. We subtract it off, and we get to 4 again. But we're out of 4 again, so when we have a 0, we'll bring the 0 down, we're going to have 40, and we'll get yet another 6, right? So then we do 6 times 6, 36, and we get a 4 again. So this is just going to keep on happening forever, right? We're never going to actually stop with these 6s. So there's a couple ways of writing this. We can write 224.16, and then the 6 goes on forever, right? This isn't going to stop. So to indicate the 6 goes on forever, oftentimes we put a little bar on top. So we'd say this is 224.16 repeating. And this little bar has a name. It's called a vinculum. But I'll be honest, I've never heard anyone actually call it that. It's just technically what it's called. A couple other ways of writing this is 224.16. And then to kind of indicate that the 6 is going on forever, maybe you write a couple of them and then put a dot, dot, dot. This dot, dot, dot is called an ellipses. Now, one thing that could maybe be a little confusing with the ellipses is that it's not necessarily clear that it's just the 6s that are repeating and not the 1 part here. So that is something you have to watch out for. So these are the main ones I'll be using. There are some other notations for repeating decimals that are used in other parts of the world. For example, let's say I had the decimal 0.141 and the 141 is repeating, right? So this is basically just 0.141, 141, 141 over and over and over again. Another way that some places write this, very similar to using the vinculum, is just using kind of an arc instead of a straight line. So you might see that notation being used in a couple of Latin American countries and Spain. It's not super common, but it's a thing. And this last one you'll also see in a few places on Earth, maybe in like the Middle East, in Europe, in some Asian countries, and that is using a dot above the repeated part. So the idea is you put a dot over the first digit of the repeating part and a dot over the last digit. So this indicates that the 141 is repeating. So if we looked at 224.16 repeating like we had before, we would just put the dot over the 6 because it's just the 6 parts that is repeating. If I had a number like 0.1 6, 7, 6, 7, 6, 7, and so on and so forth. So the 6, 7 is what's repeating. Then the way we would write that in the dot notation would be using a dot over the 6 and then a dot over the 7, because the 6 is where like the repeated part starts and the 7 is where the repeated part stops. So it's this region here that's getting repeated over and over again. So that's just like a little side note on repeated decimals for your information. But for most of the videos, I'm just going to be using either the bar or the vinculum and the ellipses. So that's a bit of a review on long division and repeating decimals. And now that we have that covered, let's go on and use that for converting fractions to decimals. And I've basically already said how to do it. You take your fraction and you express it as division. All right, so that's step 1. And then step 2 is long divide. And then you have your fraction. You're done. That's literally it. So, for example, a quarter, all right, if we're looking at a quarter, what we do to get that fraction is we take 1, that is our dividend, and our divisor is 4. And we see, okay, how many times does 4 go into 1? It can't, right? So we have to immediately put the decimal 0 here. Right? 1 is the same as 1.0, so we're good to go with that. So now we're kind of looking at 10. How many times does 4 go into 10? Well, it goes in twice, right? Since 2 times 4 is 8. So we subtract off 8 and we get a 2. And one thing we have to be mindful of is that there's technically a decimal here, right? The decimals always need to line up. And since there was nothing, no 4s that could go into the 1, we also have a 0 here. So it's a 0.2. So then we have a 2 here, right? That's still a remainder. So to get rid of that, we're going to put a 0 here, bring the 0 down. We have 20. How many times does 4 go into 20? It goes in exactly 5 times, right? 5 times 4 is 20. So we get the 20, we subtract it off, and we get 0. So now that we have 0, we know we're done. And that means that 1 over 4 is the same as 0.25. Right? We converted into division, 1 divided by 4. The numerator divided by the denominator. We found the decimal, and boom, we've converted our fraction into a decimal. Awesome. Let's do another one. How about 3/5? All right. So 3/5, that's going to be the same as doing 3 divided by 5. So we'll put that into our little division box here. So 3 is our dividend, 5 is our divisor. So 5 can't go into 3, so let's put a 0. And to actually be able to continue going here, we're going to have 3.0. All right, because 3 is the same as 3.0, and we'll put the decimal above it just to make sure that all of our digits are correct. Right, this is the 1 spot, this is the 10th spot, 100th spot, and so on. So how many times does 5 go into this 30 now, which we're kind of treating as 30? Well, it goes in 6 times, right? 5 times 6 is 30. So we have a 6 here, and then we subtract off 30, and we get 0. So there's no remainder. So 3 over 5 is equal to 0.6. Let's maybe do a bigger one. How about like 3/16? All right. So we're doing 3 divided by 16. So we'll have a 3 and we'll have a 16 right here. All right, so how many times does 16 go into 3? Well, it doesn't, right? So we put a 0 here. And then we will add in our 10th spot, our filler 0, which again, it's the same as just 3, just like we did with this example over here. So how many times does 16 go into 30 now? Well, 16 times 2 is 32, so that's already too big. So it only goes in once. So 1 times 16 is 16. 30 minus 16 is 14. So then we have to do another filler 0 in the 100th place and bring the 0 down. So now we're looking at how many times 16 goes into 140. So for this, you might have to do a little bit of guessing and checking. So I might start with 7. That would be my first guess. So if we did 16 times 7, let's see what we get. So 6 times 7 is 42. 7 times 1 is 7, plus 4 is 11, so we get 112. So that's close, but I think we can cram some more 16s into there. Probably just one more. So 16 times 8 then, we would just add, it'd be adding 16 to 112. So 16 plus 112 is 128. And then if we added another 16 to this, we'd be at 144. So that's too big. So 8 is the biggest we can go. So we have an 8 here. So 8 times 16, that's 128. So we subtract this off, and we are left with 12. All right, so now that we have a 12 here, again, we're going to have to add another 0 because this isn't a 0, so we have to keep going. So we're going to bring the 0 down. So now we want to see how many times 16 goes into 120. Well, we already know that, right? We did some work over here. 16 times 7 was 112, and that's going to be the biggest number that gets into 120 because 16 times 8 exceeded that. So we're going to have a 7 here, right? 7 times 16 is 112. So we can subtract off 112 from 120, and we just get 8. And then we're going to have to add in yet another 0, and we're going to have 80. How many times does 16 go into 80? Well, you might recognize this one. This is 16 times 5. 16 times 5 will give you exactly 80. And so we do 5 times 16, we subtract off the 80, and we're at 0, so now we're done. So it's a bit of a longer decimal, but we are able to complete it, right? We have 0.1875. So that is how we express this fraction as a decimal. And let's just do one more for the road. Let's do 1/3. All right, so we're going to start with 1, and we're dividing it by 3. So we see, okay, how many times does 3 go into 1? It can't, so we'll put a 0. And then we're going to want to get decimals, so we're going to add a 0.0 here, and we're going to add a decimal up top to make sure our digits are correctly lined up. So how many times does 3 go into 10? It goes in 3 times, right? So we have 3 times 3, that's 9. 10 minus 9 is 1. All right, so now we'll do the same thing. We'll add a 0 here, bring the 0 down, and we see, okay, we have 10. How many times does 3 go into 10? Oh, it goes in 3 times. That's 3 times 3 is 9. But we're getting a 0 again, and you see where this is going, right? We add a 0, carry the 0 down, 3 goes into 10 3 times, and this cycle is going to keep on going forever and ever and ever. It's never going to terminate. So because of this, we just say that 1/3 is the same as 0.3 going on forever, 0.3333, or we could just write 0.3 with the bar over top, 0.3 repeating. So this 3 never terminates, so 1/3 is this kind of interesting decimal where it has infinite places, but there is a pattern to it. It's just a 3 happening over and over and over again. So I hope you found that video useful. Basically, this is just a concept that you've learned previously. It's just long division, but now we're using it in the context of fractions are division. And again, if you haven't seen the last video, I strongly encourage you to do that so that you really appreciate why fractions are the same as division. So in the next video, we're going to practice this a little bit more just to make sure you're nice and solid with it. And then afterwards, we're going to look at decimals to fractions, which I think is a little more interesting. But that's going to do it for me today. Thanks for watching. Have a good one. Stay groovy. Maybe subscribe if you haven't. And I'll see you in that next video.